whether it's normal or not. Anyway, so let us start our assignment 3. So we start from design a class called universe, right? That's the very beginning. Okay. So new project again. Visual C# position, location, so change it to the desktop. Windows application, so it's R07. R07. Assignment 03. So it's my convention for the solution there. So that will make everything stored in a solution folder. So make sure this checkbox is checked. Windows Phone application, C#. Right. And from now on, I will pay attention to the naming of your UI controls. For example, don't just let Form 1 deep there. It's not proper at all. I mean, pay respect to your assignment, right? It's not core. The title is not Form 1. So try to change it a little bit. And also, class name, if you stick it on Form 1, it's all right, but it's not professional at all. So try to make it change because it is closely related to the class name. What the instructor cares is that you do name the class and the object in a meaningful way. I mean, your coding, all right? So I might prefer main form. Class name as a main form. Or you may call it main UI or whatever, or the application name is fine. And properties for the first stage, we might let the user, right? If the user kind of click a button, then a new universe will be created. And also, the user interface will be popped out. I mean, for the user to specify, for example, the title, change the title, and also the X minima, Y minima, such kind of thing. So later on, we will have this kind of user interface. All right, so probably later on we will move back to this user interface. So first thing is that we try to add a universe class. So either way you can, well, since it's see, so the current projects do have a C# file, right? It's not just C#, but also has a .design.cs. So that is the source code. So we try to add a class to our project. So right here, right click on the projects and then add. You can directly pick up this option. You kind of add a class, or otherwise you can new items. Okay, both of them will lead to this dialog to let you confirm what kind of item will be added to your project. So by default we have C# and then class 1. Class no, okay, not class for you. It's simply just a class. Weird, not class for you. SQL, not for SQL. That should be a page right there. Class right here. So make sure you highlight this guy. It's a simple class. Or otherwise, you right click on your project, add a new item. Just specifically click on the class itself. Right. So by default, again, it's class 1, class 2. It's meaningless at all. So make sure you do specify the class name in a meaningful way. So we try to call it universe, UNIV universe. You can name it so-called discourse or universe for short. It's okay. So up to you. You can name the title by yourself. 你可以用你自己觉得习惯的名称。So Visual Studio basically means prepare a skeleton of the class for you. Okay, so we have a class universe right now. And pay attention to that. By default, the class, the accessibility is what? Is that internal. Even though the internal does not show up, but by default, the class definition right here is internal. Another option is that you can specialize the accessibility to be public. The difference between the internal and public is that if you define a class as public, which means that other guys, if you wrap up your project, your whole project as a so-called libraries, then another guy is written the source code written in C# or Visual Basic. They can use your class directly if you declare that class is public. But right now, if we do not specify any accessibility, it is by default internal. Meaning what? Meaning within this project, all the class or the object can instantiate, can use this class. 所以没有特别声明说它 class 是 internal。那 public 是 open to the other guys can to use my class。other guys 是 mean 什么 ？mean what? Mean other execution file， 别人写的那个 exe file， 别的 project can use your class。In this way, you need to declare your class as public, but by default, it's internal. 那 another probably 可能是 private 哦，private 大概应该没有用哈，因为 class 大概通常是 internal， 或是 protected 的哈。可能另外一个 accessibility 是其他应该 PLT 系列应该 protected 好，也不行。好，命名空间 private property internal。好 ，never mind 好，我们 by default so far you need to know that the accessibility is internal. So universe has what? At least you have a title, right? So we might have title string, title title. Okay, it's a good. I mean, so for you, and also we might have what you have thinking about. Probably you have double X mean, or make the name meaningful. Or probably you would like to have what also called lower bound. Up to you, totally up to you. Try to make a variable name meaningful somehow. Lower bound. If I call it lower bound, you be upper bound anyway. And as I just mentioned, you had better special initial value for them. So probably I might call you NIVERS universe. What? I don't know. Well, and probably your lower bound might be 0.0. Upper bound probably 10. It's pretty up to you. So it's very beginning we think about class, right? Class can contain data. But right now we are not going to specialize public because that will violate the paradigms of object-oriented design. We need to encapsulate our data. So if you did not specify public, by default, title is private. The other guy, the other object cannot access the title, cannot change the title for you. So up to this point. And also we have what? We have increment. Increment, right? Increment, which means it's the resolution. So if the resolution is probably 0.1. So meaning at least right now I have 101 point, right? 假如说0.1是1,000个，这个是那个 universe 好。So basically universe is try to provide this kind of accesses for the user to specify their function, right? For this function. All right. So in order to use it, usually we will provide a constructor. But sometimes we don't need a constructor. So far we do not have a constructor, right? But it's okay. It still can be running, all right? So right now we have a class ready there. But back to our main form. Suppose right now I provide a button. Don't let the naming button 1, button 2 left in your source code. Later on you will receive not just a warning, just a comment saying that the name is poor. So btn new universe. Okay. So in the bottom face, we specify this text for the user, new UNIVERSE, new universe. Okay, so in your form, you try to manage well, I've already said, right? So I've already should define on a universe. So you kind of provide a button for the user to create universe. Okay, so it's very simple. So we kind of subscribe the click event on this button by select it and pop out the Thunderbolt pages. So double click right here. So it's a meaningful function name, right? BTN new universe click. So right now we will instantiate an object or universe class. Where do you keep it? If you did not keep it, later on we will see nothing at all. So in this case, probably the easiest way you might have a universe. See, once you type a UNI, as you can see, the IntelliSense has says that well, we have a class ready for use right now. This class is defined by ourselves, right? Just previously, see, so you can. So it's a kind of data type right now. I might call it my universe. Somehow there. All right. So once user click the universe, right? Then I can new it. My universe. Assign with a new. Since every object or class is a reference, so you need to instantiate runtime during the runtime. Right. As you can see, well, once I complete the typing about new, universe has been highlighted. This is a class. So right now we try to invoke the constructor. Actually, it's a constructor. So it's a function, special function invocation. So right now it's a function invocation. So I need to type the left parenthesis. It's a function call. Seeing that? Okay. That's it, just like it. But can you do anything about this my universe? So right now my universe has been instantiated, right? If I type a universe, try to access data. As you can see, nothing happened. Equal, get hash code, get type, toString. These four functions actually are derived. So even though I did not declare, this universe, I did not declare this class inherit from anybody, but internally in C# programming, all user special class are indirectly inherit from a class called object object. So object is a super class or every classes within the C#. 这个是不成规律. And because object do have these four functions, actually these four functions are virtual functions. So naturally, once you define a class, a new class by your own, this class has been indirectly inherited from object somehow. That means inheritance. Now you don't need to specify it because it's internally inherited from an object. And since these object class do have these four functions, as you can see, equal, get hash code, get type, toString. These four functions are actually inherited from object class. 好，所以自然而然他们就有。But what about the data? Because right now data title, I like to change it, right? Somehow I like to change it. Maybe this is age, universe is age or temperatures. But I try to change the title, right? It is not possible because the title right now is there's no accessibility special, but by default it's private. By default, if I did not specify anything for the data, it's private. And if I kind of change it, like what you have done in the previous assignment, I declare that as a public. Okay, right now, my universe has title public, but low bound, upper bound increment. Okay, it's a typo. Increment. It's okay. So right now I have a public data. I have 3 private data. So back to the main phone again. I try to access. As you can see, oh, okay. I can access the title. So right now, the phone object can directly modify title value of a universe class object, which is not considered a good object-oriented implementation at all. OK， 所以我们不想再这么做哈。那 similarly, so again, if you kind of you see what I have done, if I declare that these lower bound, upper bound, and increment are all public, back to the main phone. So right now, this is the guy, main phone object. Main phone object. Try to access my universe. See, if I type my universe dot, as you can see, right now I can modify lower bound, upper bound, increment arbitrarily. Upper bound, if I type upper equal 10, my universe dot lower bound equal 100. That will violate the integrity of your universe, right? This is not the way I like to declare all the data as public. That is data encapsulation philosophy. We are not going to specialize our data as public because other guys might screw up the values of my parameter, and then later on I will have trouble with others objects. Okay, so this is the idea. So we are not going to let this data appear like this way. So instead, in old days, we will do what? We will declare as a public function, saying that this was void set lower bound. And the user needs to provide a double x, for example, for us. So we kind of, well, this is a new value. I can directly use it to set my lower bound, right? Let's just use this. It's similar, right? It's similar to you declare your lower bound as a public. If a user special x equal again larger than your upper bound, it will ruin up your integrity again, right? So those days we kind of use this one, and since it's a private, right? It's a private. So if a user want to get the value of lower bound, usually the class design will provide this way: set double get lower bound. So user does not need to supply anything. And within this function, I simply say return lower bound. Okay, so we encapsulate our data and then provide proper function for other guys to get the value, to set the value. If this value can be modified by the user, we do it in this way in older day. Okay, so in this way. So again, right now since upper, well, what I have mentioned just lower bound. All right. So our lower bound cannot be directly accessed, right? But if the user want to change the lower bound, the only way he might have probably if the user want to get the lower bound, all right, he might prepare a local variable, say WLAB equal what? Equal my universe dot get lower bound. So through this way, through function call, other guys can get the data or an object or set the value. So for example, if my universe dot set lower bound, and this time probably user supply 1000. That will screw up your integrity, right? So let us try to debug it. So right now we have a class ready there, universe. So we kind of execute our code line by line to let you see what's going on. Once you instantiate an object. So once button click, right? So we are in what? We are within this object, main phone object. Main phone object do have a member data called my universe, right? There's no any other member data exists. But right now we are in what? Within this function. So within this function, we have local variable sender E. We have a sender E, right? We also have a local variable called LB right there. So initial value has been specified. What about this? Because right now we are in a member function. This member function btn click, and the object. This is member function belong to an object. An object is just the main phone. Main phone we call this. Property called this. So this stands for the object of the main phone. A bunch of data has been inherit from the main phone. Right now, we just have customized data, right? My universe is my data member. But a lot of variable property and the data has been inherited from form. So if you unfold this object, you can see a lot of property has been inherited from form. So don't underestimate the main form object. Right? Main form object is inherited from the form. So form has a bunch of property, can be specialized, can be modified by the user. But how about my universe? See, this is my universe. I kind of add my own data for the main form derived class right here. So my universe right now initially is none. It's a reference type. 它是一个参考型别 reference type。骨子里头它就像 C 的 pointer 啊，像 C 的 like C 的 pointer。You need to extension an object in the heap, then you have a data specified 哈，所以只有在 new 之后才会有 data。So we are about to execute this line. Okay, it's right. So once I execute it, when I press F10 key, we will go to the universe definition. Right side will be executed first. Oh, okay, I denied. Okay, let me try it again. I hit F11 key to enter the function. Okay, to let you see what's happening. I mean, it's in extension class. So we are about to extension an object or universe class. So I hit F11 key. I came to the definition of the universe. So up to this point, computer try to access a memory. The size should be necessary for a universe. And right now we know the universe has just two memory data, extremely 3, extremely 4, lower bound, upper bound, increment. So a lower bound will take about 8 bytes, and a string just 4 bytes. But dynamically we instantiate some constant character string there for universe X. So initially title is none, right? It's none. String is a very special type. Later on we will talk about that. So initially it's a none. Once this right-hand side has been executed, we'll actually computer to access the memory, try to put a U in the memory, N, I, V, E, R there, and then return the starting value, starting address back to the title. So up to this time is executed. Title to have value, universe X. How about row bound? Initial 0, right? 0. Initialization. Initially it's 0. Initialize with 10, right? Initial with 1, 0.1. Alright, so right-hand side has been instantiated. Memory has been created. And then starting value will be sent back to assign to the my universe. So up to this point, my universe has not been assigned yet. Still now. So once this line is executed, my universe can access the data right there if you unfold it. So increment 0.1, low bound 0. It's reasonable. The integrity has been stable there, 10. It's all right there. And if I hit this, try to execute this line again. So I try to get the lower bound back to the LB, right? So I hit L11 key, came to this function. This function does not do anything, simply return the lower bound. All right, lower bound just returned it, lower bound. So return, double back, assign to the LB, so LB is 0. But right now, user, who is the user? Object on the main phone, try to change the value of lower bound, okay? And use it 10,000, I think it should be 10,000, 10,000, right? So we are about to execute a set lower bound. So right now, user has special x equal 10,000, right? And then if you implement it just that, well, you did not check anything about x value directly assigned to the lower bound. What will happen? Your integrity has been broken. See, lower bound right now is 10,000, upper bound is 10. It's not your integrity. It's not your intention, right? So how can you maintain integrity? Right here in your set function, especially you need to check that if x is what? It's equal smaller than the current upper bound. Then I do it. Otherwise, I will not do it. See, that is the guarding. The purpose is you need to guard your integrity by yourself, by using this set function. 为什么我们要用 function？ 就是我们把关，在这个地方把关，我要 maintain 我们 integrity。Think about that 哈，我们的 low bound upper bound 要 maintain low 一定要小于 upper 一定要小于那个 increment，right？ 好，这个是起码的。但是 somehow 呢 ，you need to think about if it is okay, if it okay, I will change it, right? So if it is okay, I will change it. But how about the philosophy? How about the increment 0.1。好 ，if the user change the 假设说你的 velocity 是 if your velocity right, well my universe or the resolution, I want to maintain the resolution, right? Resolution. For example, if a user change the lower bound, upper bound, I will maintain at least 100 point will be drawn, right? So you need to update increment too, right? 好，所以这个时候呢，哈，if it's okay, if x is smaller than the upper bound, and if my purpose is that my increment should maintain at least 100 point will be drawn. So in this case, you need to update your increment too. To maintain your philosophy, I mean your universe. 好，假如你的 universe 是要 hold 100 point 的 solution 上，那你的 increment 会怎样 ？Low upper bound, your upper bound minus lower bound divided by 100. Well, 假如说要 keep, if you want to keep 100 point, now we're divided by 99. 好 ，starting point 跟 end point， 每天呢，这是 up to you. 所以你的那个 set 会在这样作为。好 ，OK, so let us try it again. 啊，所以 in this way, 另外一个这个 ，so another case is that my universe that set lower bound, probably minus 10.0. OK, 好，那我们 again 好一樣哈。那 in this time I'm not going to drag down to the this function. I simply hit F10 key. So lower bound right now is 0. So again, I hit F11, try to enter this line. So currently x is 10,000. 10,000 is 10,000 smaller than the upper bound 10? No, nothing happened. You still keep your integrity somehow, right? So in this case, if you check about the well, I cannot check it anyway. I cannot check anything anyway. How about the next time? If this time I set lower bound into a new value, minus 10. So right now x is minus 10, right? So minus 10 is smaller than the lower bound, upper bound, right? It's okay. So right now I kind of extend my range from 0 to 10 up to the minus 10 to 10. Okay, so it's okay. It passed the guarding condition right now. So x is the new x is minus 10. All the value is 0. So after this assignment, and my lower bound has changed to minus 10. How about increment? Original increment is 0.1, right? In this philosophy, I kind of maintain 100 point in my resolution. So increment has been extended to 0.2 whatever. Anyway, so maintain your integrity within your class by specifying where SS function and modify function themselves. OK, 那大概这样哈。那我们现在还 another story is that, well, we know that universe will have so-called x's showing up, right? Because we will have graphics display to display the fuzzy set, including the universe and the fuzzy set. So right now, we like to add a very object which is related to the Microsoft chart. So back to this main form, we will have a chart, right? Spatial data. And once users say that you like to create a new universe, we will add what? We will add a so-called chart areas. So this chart area will be instantiated by the form object because that is the responsibility of the form object, and then pass it to the universe object. Anyway, that is the whole idea. So initially, this time there will be nothing special in advance at all. So go to this, select this guy, this chart 1, then we move to property. So property there. So right now the chart area, the notation, okay. Chart area. Initially there is a chart area prepared for you, right? We cannot erase it. And how about the series? Let's check it. Series. Remove it. So empty, right now it's empty. But if so once a user click this guy, So the universe will have a so-called chart area associated. That is my design. You can have your own. Okay. Anyway, so let us back to the universe definition. So the universe right now we think well we will have a chart area. Chart. A-R-E-A. Never mind. Even those right now the editor does not recognize this guy, right? So in this case, move the cursor to the hint, the image there. Using system.windows.form.data visualization.charting. Alright, so right now we know chart area has been specified within this namespace. So you simply click this one. The Visual Studio will type this line for you. So a universe will have a chart area associated. Anyway, so we give the name, the area. Well, the area, okay, yeah, anyway, the area. So right now it turned out that if guys want to instantiate a universe, that guy needed to provide a chart areas for me. Because later on, the file set defined on the universe will have a charting on this area, right? So again, in this case, then we will prepare a constructor to ask. See, initially we do not have a constructor specified within this universe, right? So it's okay. It's okay if you do not have any constructor specified. By default, we just C# will provide a default constructor without specify any parameter. 这个在 C# 里头，就是说你的 constructor by default there is a default constructor prepared for you. But if you have your own constructor specified, it is no longer exist. So so-called default constructor is the constructor without need any parameter specified. So we call this as a default constructor. Default constructor. If a user did not specify a constructor on its class. But right now, we like to have our own constructor, CTOR. So once you type CTOR, it's a kind of code, a secret code. We just need to know that you are about to create a constructor. So once after the IntelliSense has highlighted this for you, simply double-click your tab key. 按下 tab 键。We just need to prepare this skeleton for you. This is a constructor. But right now, we ask user need to prepare a chart area. Call it CA, and then assign the area equals CA. Okay, so that is the story. Okay, so in this way, so this is the construct. And back to the code, you see, there's a red curly line coming out because right now we just need to check the universe class definition. There is no any constructor without any parameter specification. 所以这样就不行了哈，所以麻烦出来。Once you have your own constructor, then the constructor needs to be invoked specifically. There is no any default constructor without any parameter requirement. 这个概念是这样哈。好，所以 up to this point, what should we do? We will ask the chart area 哈，这个地方哈，我们就这样哈。这个是它的 name 是 chart 1哈。Alright, so kind of change the name. I call it the chart. You can name it by yourself. So the first thing is that I prepare a local variable called chart area. Chart area. Excuse me. C-H-A-R-T, chart A-R-E-A. Again, it is not recognized, right? Because the namespace usage does not include that. So never mind, type the chart areas and move your cursor to this one. Specify this namespace using Windows.form data visualization charting. This namespace. So you recognize. I call it CA, never mind, new. We need to instantiate. So that is the responsibility of main phone object. Create a chart area and then add it to the chart. Chart added to where? Added to the chart areas collection. Chart areas collection. since chart area is a collection, so the collection always has an add function ready for you to add an element to it, to the collection. All right, so we kind of extension the form object extension chart area 的 objects and other objects. See, that is a reference， 它只是一个参考型别，一个参考，其实就是 C# 的 pointer 而已，把这 pointer assign to the chart area, so chart area is correct it, and then we pass that CA to the universe CA. Okay, all right. 我们 hit 一个那个 breakpoint， 好 ，right here， so 一个 breakpoint. So back to the user new universe, right? So initially, the local variable CA is none. It's a reference type. Once this line is executed, so CA is an object right now. So memory has been allocated on the heap. So right now we have data associated with the CA right now. And chart area, see, initially the chart do have a chart areas attribute, right? The collection is a collection. So there is a property called count. No any element because we just remove it. It's empty right now. So it's about the time we added the current CA there. So move your cursor back to the chart area. Check it again. See, count is 1 right now. So our chart area do contain one chart area now. And then since we have a chart areas object ready, so we can use it to instantiate an object of the universe. So I hit F11 key, came to the universe declaration. So up to this point, the chart area is none, right? And then since there is an initialization statement, so the computer will execute the initialization statement line by line, execute the initialization, and then enter the constructor. So if your data has initialization statement, initialization will be carried on first, and then invoke this constructor because the constructor invocation has been specified right here. So how about CA? You see, CA has been instantiated, so CA2 has its own value associated. So we are about to execute that. The area is none, right? CA has been instantiated, so we assign CA to the area. All right. So later on, change it again. All right. So let me continue to the end. Okay. So we have a chart area there, and if you hit it again, another one. We cannot see anything. Okay. Let me see. Chart area should be. Display. I think this property should be highlighted. Okay. CASS. All right. Let's try to add something. CA is chart area, and also it's a big object. Within this object, there's a bunch of property. Axis X. Visible what? The property called enable, right? Enabled equal. Access enabled true. All right. Let's. We kind of instantiate a chart area, right? Chart area do contain an x-axis and y-axis by default, and then we force the x-axis enabled, not just auto. Okay, so we just added this line to let you see there's a chart area already there. So I hit continue key. All right, so this is chart area. Again, if I hit the universe 2. The second chart area came out. Okay, so this guy came out. So you need to study the attribute of a chart. I mean, to some extent, all right, in order to make it your code. I mean, user interfaces look much more. I mean, reasonable for the user to do it. So, how about the x-axis, right? So usually, I mean, the x-axis should have should bear the universe, the name, the title, right? Since our universe has a title specified, so the title should appear on the x-axis, right? So in this case, back to the universe because only universe has its title specified, right? So once once the area, chart areas has been recognized within the universe, you can do what? Okay, the areas that x axis x, so it's an object for that x axis. And again, you can try to access the property. There's a title there, all right? So you can title doing what? This title, right? It's much more reasonable. And how about the minima value and the maxima value of the axis? See, the lower bound, upper bound, right? So up to this point, you can say what? The chart areas, x-axis, another property, minimum, set to what? Lower bound. The chart area, x-axis, that maximum, upper bound. Right? So remember that the area actually is a big object. This big object has contained several what kind of data? The minima, maxima value, and also title. So that will make our display much more reasonable. So right now I have a universe. Let me remove this breakpoint to let it execute to the end. See, universe axis. How about new universe? Universe axis. How about the third one? See, it's coming out. So we might like to use up the screen space, right? So in this case, you need to do what? I have mentioned that once. You need to practice it. So I kind of specialize this chart area because it's much more important. So I will set what? So what kind of set? It's the anchor property. Property, right? Anchor property. Then the left, top, right, bottom, anchored. So I can take advantage of this space. It can be very large. First, second, third, fourth, fifth, seventh, sixth. Yeah, you can keep doing that. So later on, we need to have this kind of user interface because later on, if for the inference system, we might have two input universe, one output universe, right? So all these chart area has been special within one chart component. So we need to programmatically add the chart areas one by themselves. So up to this point, it's okay. But how about the property? For example, later on, if a user like to change the title, and your title, since they are all the same, right? Universe X, universe, they should be different, right? For example, we might have for the inference system, the input might be temperature, might be pressure, right? So users like to change it, but we are not going to bother about what? We are not going to bother about label and text bars, such kind of things. Very troublesome for us. We might take advantage of a very high label or control later on. The control, as I just mentioned in the first hour, we will use a control called what? So we drag in one so-called property grid. There's property grid, it's control. Let me drag it one here. Well, it's look familiar, right? It's almost like the property, especially right here. Okay, so later on we will use it anyway. So the first thing is that, how about default value? Because if we use instantiate one universe, the title always universe X. This should be different. So in this case, probably our thinking is that if we keep counting, we will keep counting, keep the count of the universe object has been instantiated. Sometimes we would like to have int, see, int count. And initially it might be 1, initial value might be 1. But not every universe object to have a count, to have this count data. We declare that as a static. Meaning what? Meaning all the universe objects share one data, count 1. But how about the constructor? 那个我们 title 这个地方就把它 remove 掉哈。 But once the user instantiate universe, then I will assign title, title equal what? Equal universe. Universe. Kind of use suite, so-called suite string, $sign data. And then put count there. But in this case, the count because it's always 1, right? So in this case, it still does not work because the name is still universe 1, universe 1, universe 1. We like to let the number running. So what should we do? We just simply count plus plus. So each time an object, once an object is instantiated, the count has been forward by 1. Count 2, universe 2, universe 3, universe 4. Okay, at least the title is different somehow. I mean, for the reader to distinguish them. But again, later on, user might change universe 1 into probably temperature or pressure. We will allow the user to modify the name, right? And also, we would like the user to modify the minimum value and the maximum value. Okay, so how can we do that? See, our lower bound has been prepared with these two functions, right? This is the old version. I mean, for example, if you are still using C, C++ programming, you need to do that in that way. You need to provide a set function, a get function, in order to associate with important data. It's very troublesome for me. But right now, okay, follow me, okay, follow me. If I kind of specialize this lower bound, let's kind of highlight this lower bound. Right click your button. I think there is an option called quick movement and a reflector. All right, there is a command calling that encapsulate this field, data field. Okay, you use this one. The same one still use the original. Well, the data itself, I mean, the data or class in Microsoft we call it a data field。这些东西叫这 data wise 呢，在 Visual Studio 的那个 terminology we call it a data field，F-I-E-L-D。Which is the field is usually used in the database anyway. Database we have a data field, data column like that. So we kind of encapsulate this data field into property, turn out to be correct. So we are about, you see, that is required, right? We need to have a function to let the user set, and then within this function we kind of set up a guarding condition so to check the value. All right, I mean check the validity or the value, new value. You only validate the data can be accepted. So highlight your data field, one of your data field. Right click it, select this command. There are two options. Well, we are about to encapsulate a data field and then provide a property. 用个 property 给它好。那 initially I think you can just stick on this command 仍然使用栏位的词其他地方有用到我们 still use the field name. So click this command. Alright, maybe it's not a good idea because Visual Studio 2017 kind of simplifies this simplify this property definition way. Forget about that. Okay, forget about it because that might confuse you because we need to introduce another operator called lambda operator for you. It's kind of complicated. So right now, I will show you how to encapsulate this data by providing property. The property. So the property is that it's almost like you are defining data, but conventionally we name the properties. So let me write that for you. I'm going to define P-R-O-P-E-R property for data field lower bound. Okay, 那怎么做呢 ？Double 一样哈。A property do have a data type double, which is pretty similar. But since this property is closely related to the lower bound, so by default, conventionally, we use upper cases letter L-O-W-E-R, lower bound. if you end up with some kind of, you are defining a data field, but no, I'm going to define a property. So how about property? We will use a pair of brushes. Okay, and with this pair of brushes, you need to have get keyword. And within the get, you see the red curly line came out. Never mind. Let me just prepare this skeleton. Get is called set. If you take a look at this function, set lower bound, right? So the purpose is to try to set a new value for the lower bound. How about the get lower bound? Because the user might want to access the value, simply access the value of lower bound, right? So this function, two functions is closely related to the lower bound. Lower bound, right? To the lower bound. Right now, the C# so-called property, again, is closely related to a property, similarly. And within this pair of branches, there is a part called starting with the get. So actually, it's for the get lower bound's purpose. The set is trying to set the new value for lower bound. It's closely related to a lower bound. So how can you make sure that this capitalized lower bound is closely related to the lower bound? You can always check that. When you type this return lower bound, lower cases. So that means that if the user try to access a property capitalized lower bound or the universe classes, actually, if you want to show the value, this get function will be called. So get, you can regard it as a very particular function, but this function is not regular function, so there is no any argument passing at all. No argument passing at all. So you can think of that this just like the get lower bound function have been specialized in the lower parts right here. All right. So how about the set? Similarly, but how about, because set lower bound, we do get we need a variable, right? A new variable for the lower bound, right? So right now within the set part, there is a default local variable called value, VLU. As you can see, it is highlighted in blue color, so it's a keyword. So this value then is exactly the parameter required for a set function. 就是你可以假设这是新的 value， 这个从这边进来。So value will be set to where? Will be set to the lower bound. If there is no any regulation on lower bound at all, you can do it this way. So we try to deal with the lower bound by specifying a property capital lower bound for this lower cases lower bound by providing a get function, set function. This get is not a normal function, but intrinsically this is a function. Anyway, this is a function. Set does not have any argument, but by default there is a parameter passing by the user specification, so it's called value there. So similarly, we need to have God condition, right? So actually, you can copy the same logic within this set. See, the upper bound, the x value is entered through this parameter, right? So the current x turns out to be the value. If the new value is keyword, okay, there's no any, it's not local variables. For the set, the new value should be put in this value variable. So if it is lower than upper bound, then I will allow it to do that. Okay, so that is the whole idea. I encapsulated my lower bound, but somehow user need to change it. Needed to change it with a new value. The new value will be this change will be invoke this set function, and the new value will put in the value there. I needed to check the value whether it will violate my integrity or not. So I check the validity right here, and if it is okay, I update the value here. And also, so I don't need this line. It's only in this case. Okay, so I have created a so-called property ready for the use. So later on, as you can see, right now I'm not going to invoke the set lower bound. So I'm not going to use my universe get lower bound. See, which is similar. So right now I have double, call it mean. value. So you see, similarly, I use this object name, my universe, try to access something, Oh, excuse me. I need to go back to the universe. Since right now I have defined a so-called property, it's not data at all because it's private. But again, by default it's private, so I need to declare that. So usually we will define a property and declare that property as a public to let the user access it. Otherwise, it's meaningless at all. So定了一个 property 就是让它 public. So after this modification, let us go back to the main form. So again, if I use this object name, my universe that try to access something. As you can see, there is item coming out range. As I mentioned before, you guys are familiar with this range, right? It's property, we call property. You see, in main form, once you click something, well, this is a property. Actually, this is property, right? These are all the property. These are all the property. So property, the symbol is a range. The shape is a range. So right now, I try to get value of my universe that try to access this property, capitalize row bound. So later we'll see what's going on. And similarly, we'll try to change it. And how to change it? My universe that row bound try to assign a new value, 10,000. My universe row bound equal -10. So let us go through with this code, right now. Select breakpoint there. So remove this point. Okay, new universe. So up to this point, a universe has been created, right? So unfold it. You see, initial value is the low bound 0, upper bound, low bound 0, lower cases, right? It's data field, upper bound field. And how about the property? Low bound is 0. So child error is already universe 1. It's okay. And then so we try to what? We try to get a low bound assigned to the memory, right? So if I hit a F11 key, F11 try enter the function. I cannot go it. All right. I need to set a breakpoint. So let me stop it again. So I go back to my unit. See, I set a breakpoint right here. If this line is executed, then the code will stop here. So back to my main form. So we are about to execute this line. So I hit F11 key. You see, keep the way. I simply want to get lower bound. I simply want to get the value of this property. Upper case is lower bound, right? But again, we will execute this get function. So the get function simply return a low bound value back to it. So come to this line. So invoke the set part. Execute the get parts. Once the user want to access this property, so property is exposed to the user, but data has been privately encapsulated. So right. So mean value is 0. And how about this setting? I try to use the 10,000 new value to try to set the lower bound property. So property is quite similar to the, quite closely related to the data. But once you want to access it, want to change it, function will be invoked. So if I hit F11 key, well, let me see what's going on. All right, so because my breakpoint is right here, so I should set breakpoint right there. So let me start it again. So this time I hit F10 key. Again, since we have breakpoint right here, so it return low bound back to mean value. And then I'm about to change the low bound property. So I hit F11 key. See, came to this point. How about the 10,000? You see, the value is a keyword. Move your cursor, mouse cursor to this value. 10,000 here. So we do not specify any parameter, right, for this set function, right? But by default, this value has been kept in this keyword value. Value right now is 10,000. It's 10,000 smaller than the current upper bound is 10. No. So nothing happened. Lower bound still 0, not 10,000 at all. So that is the purpose of the game. Well, actually, I should set a breakpoint right here. Let me run it again. let you see it. Right? So we try to get a lower bound value, so came to the get part. And then I try to change a new value, lower bound into 10,000. Okay? So the current lower bound, you see, return 0. So I kind of hit F11 key, came to this point. Nothing happened. Nothing happened. All right, so how about the second line? I try to change the lower bound into the -10, right? So I hit 11 again. Okay, right now, how about the value? -10 right here. So -10 is lower than the 10, right? It's okay. It's okay. So the code will be executed. Integrity has been maintained, all right? So lower bound originally is 0, right? But new value right now is -10. Okay, updated. Lower bound has been changed into -10. How about increment? Because this philosophy want to maintain a 100-point resolution. So the increment also changed from original 0.1 to 0.2. It's okay. All right. So up to this point, the integrity has been maintained by the philosophy. But again, back to the usage or the usage. Well, it's very troublesome for us to do it. But right now, since you have properties visual, what is the beauty of this guy? Let me show you. Right. So once I use a new universe, then universe is created right here, right? My universe has been defined, and then we have changed into -10. So you see, there is a control. There is a control called property grid 1. All right. So I rename it the PROPERT, property GRID, the property grid. Property grid, it looks like the this property. See, it's like a grid. So again, similarly, right? But you simply hold all the possible property of an object. All right, let me show you one thing. Initially, if you drag in a property grid, see, this is the object, right? This is the object, right? So if I kind of click this one, it's the BTN new universe, right? So if I highlight this property grid, there is a property called what? Selected object. Initially it's none. If I change it into the BTN new universe, you see, I kind of have, like I have a property window showing up right here. So that is the beauty. If you design a class, put all your related data as a property, you can show the property name and the value in this property grid control. 这是我们要用它的地方。那我们看一下initially. Let's take a look at this usage of property grid. So you see, this is the property of this guy, right? Or this button. If I change it, for example, back color, I kind of change it into property green. You see, I dynamically let me change the property of this guy. This is the object. This is a button object, right? It's associated with this control. So and since this guy has a bunch of property defined, I can use property grid to host the value of the property, and I can change it right here. User can change it. So including the name, including the value. You see, if I change the text, alphabetical order, and I select text there. I change it. You see, it changed it too. So forget about the label, forget about the text box. We like to use this property to host a bunch of probably the parameters 3 or 4, doesn't matter. I will just pop up here. So okay, so once I have a universe ready, all right. If I have a universe ready, called my universe, then I can reassign. I can reassign dynamically. What property grid? See, we have PROPERTYG. Right? We have this object, the property grid, and I call it the property grid. Selected object. Selected object. Reassign it to what? To my universe. See, this kind of beauty, right? So, line by line. Initially, it is associated with this button, right? Right. Again, you can make sure that again. So I change the back color again. This time I change it to yellow. So it's binding is combined with this button. But once I hit my new universe, so I kind of remove this breakpoint, 9 by 9, 9 by 9, and set the breakpoint right here. All right, execute this one. So far, the select object is what? Is the bottom one. See, the bottom one, new universe. How about my universe? Universe is another object has been instantiated correctly, okay, and also logbound has been changed to a -10. So I run it, F10. Move your cursor back to the select object. Right now it's the universe. So if a universe object do have a bunch of properties, this bunch of properties will show up in the property grid for the user to modify it. See? Right now, you see, here just one logbound -10. All right, so in this case, user can interactively change the property value through this property grid. So right now, if I change it, well, I have better resume the breakpoint. If I set a breakpoint right here, setter, right? Okay, setter. Okay. And then go back to the application. So right now, if a user like to change, well, my logbound should need to change -50. When the user hit enter, it will invoke the property change. Enter. Property change came to where? Came to this logbound property. See? So how about the value? You see, move your cursor -50. Smaller than 1. It's okay. So keep going, update it, increment, change it. Let me execute it. So right now the logbound has been changed to -50. All right. So we like to let the user modify their value right here through the mechanism of property and the property grid change. And so in this, again, if I add another one, the second one is right here. So how about this value? The original is -10. Right now it's -10 too. So if I change it, hit 50 right here, it passed. Okay, it's passed. But right now, it's not, I'm okay. I mean, so on is not completed yet. But it's okay right now, so we have property grid. So later on, please, do it by yourself. You need to encapsulate all this stuff, okay? Upper bound, probably because of the philosophy is that I cannot maintain 100 points. So increment probably will not pop up for the user. But, well, for increment, because you see, for the increment, it is always, because the philosophy is that it maintain 100 points, right? So increment will not be modified by the user. The increment will be purely modified by ourselves, right? So for the increment, probably what you need, you kind of, so I close it, I unfold it. So right here, I might declare public double. I keep the right, CREMEN, increment. But in this case, I will not allow user to modify. I simply set a getter. So getter simply return increment. That's it. Simply get return. So that means this property is read only. It is not intended for the user to change it. The increment is maintained by the integrity. That means within my universe, I simply keep 100 point resolution, 100 point. That's it. So my increment is maintained by myself. So it's a read property. So in this case, you see it's public, all right? So in this case, as you can see, once you instantiate and universe correct, as you can see, this property has been shown up right here. Increment right now is 0.2, but user cannot modify. It's shown there, but it is unable to let the user to modify it. 好，所以它可以看得到哈，大家。All right，你们需要休息。好，但是我们把握一些时间，我们继续。假如说 if you want to go to the bathroom, I think you can just do it by yourself. So let us keep going on. So it is our universe ready for us to use. But later on, we try to design a family of fuzzy set class, right? All right. So we start from this idea. So fuzzy set should be defined on a universe. So as you can see, so the current philosophy is that if you want to create an universe, user needed to prepare what? Prepare a chat area. right? Child area. So that's the requirement. So let us go back to our design of fuzzy set. So we add a new class. Add class. And we must start from designing the upper class. Okay, so we call fuzzy set. DZY. Fuzzy set. It's a generic fuzzy set class. So by this time, you know that fuzzy should always define on a universe. So you will design and construct a CTOR, right? CTOR. So IntelliDesign highlight simply double-click tab key, and you ask for the universe. I'll simply put a U there. So you need to record it somehow. You need to record it. So I will specify a data member, a data field, there, UNIVERSE, the universe. So what are you asking is that user need to prepare a universe for me. So basically, what has been tested is simply a reference, not the object itself. 它就是一个参照而已，是一个。所以将来 universe 只会被 new 一次 ，will be instantiated by the new operator only once. But its reference can be passed around, can be copied, many copied, so everybody can access this object through the reference. 好，所以这个地方的 universe， so seeing that we did not renew any object or universe at all. We simply get a copy of the reference and assign to the universe. So the universe is right there. So for a fuzzy set, right? Right now, it's a fuzzy set. It's not a simple function at all. So each fuzzy set will have its own title, right? So similarly, we have a string. We cannot define data field title. And then we will have what? Parameter value, right? So double. And since it is an array, so this is the C# convention. So if the data type is an array always should be dynamically allocated, all right? So parameter values, well, it's in plural, so it's a use values double query there for you. And remember that last time we said that a function should have similar function called get function value, right? So right. So I have declared a public function. I will return a double back to you, and I call you get function value. And if you give me the x value, DOUBLE x value, I will return it to you. But since we are designing a generic fuzzy set, we do not know the detail. The detail get function value will invoke different kind of function calculation, right? So that is the responsibility of derived class from fuzzy set. So fuzzy set is the superclass, so we sometimes call it parent class or superclass. If the detail implementation will be done in the derived class, then we will declare the function in the superclass as virtual. So we call it virtual. We are TUL. Virtual function. In order to eliminate the warning, so you had better return the default value. Return 0.0 anyway. So for a generic fuzzy set class, we have a bunch of parameters, right? And we also have double value there. And we need a universe. So user need to provide us with a universe. Okay. So universe assigned to it here up to this point. Okay. And also, in this time, we also knowing that we need to maintain the point by ourselves, right? So for a fuzzy set, we will have series, SERIES. It is not recognized, right? Because the namespace up using does not include that. So again, move your cursor back here. So how about the series? Again, it's the namespace should be the Windows Phone visualization charting. So series. We call it the series. All right. So it is the responsibility of the fuzzy set itself. The universe was provided by the caller, by the caller who instantiated this fuzzy set. But the series should be done by ourselves. So fuzzy set. So right now I have a universe. You ready? Then I need to instantiate the series new. So for 1 minute, you need to instantiate the series. Once intelligence show up this image for you, meaning that mini series will have 3 constructors for you to select it. The first one, we do not need to specify anything. How about the second one? Name should have a name. Series should have a name. All right, series should have a name. Okay, name should be different. All right, if you do not specify a name, naming convention will be. How about a variable? So never mind, we should simply invoke the first one. So we're series ready for that. And the series have another property, I believe, the series chart areas, right? Chart areas. So chart area will be assigned with that this chart area. So you will have a chart area, right? Maybe we should have because right now you see we have a universe ready. But right now, you see, universe have a chart area, right? And they have universe has x-axis. Right now, our series will be added to that universe, and also that chart area, and also our series will be included by the chart. So it's the procedure is a little bit complicated. So let me do what? Let me ask the universe will provide a function for us. You see. I kind of ask that the universe will provide this function. So I guess the universe right now, since we have the universe, so the universe add a fuzzy set. And then I put this meaning what? This fuzzy set to the universe. Okay, so we did not define this function, right? So again, series, no. Define not. Okay, let me change the name. Add fuzzy set series. So I put the series within that. So later on, we will add this function. The universe should provide a function called add fuzzy because the universe has the chart areas, right? So the chart areas, the series will be assigned their value. I mean, it's the chart area to the right one, and also the series will be included to the series. So we will let this function do the dirty job for us. So the universe will have an add fuzzy set series. So I type this one, right? So currently there is only function. So never mind, we'll let the Visual Studio add this function for us. See, move your cursor to here. Because right now the universe does not have this function, right? Let the universe generate this function for us. So 产生方法哈 this command. So red kernel will eventually disappear. But when you go back to the universe, a new function has been special for you. See, add fuzzy set series. The parameter should be the series, and by default it's internal. But right now we like to declare that as a public. So nothing has implemented right here. So in this point, back to the universe, right? So universe provide this function add a fuzzy set series. So right now this is series. Want to add it to your chart area because the chart area you maintain it. So you kind of change the property of the series. There's a property, chart areas. All right, chart areas. It's a name. It's a name, okay? It's chart area is a name. All right, it's a name. Special into, see, the areas right here. The areas. Name. Assigned to it. And also, through the chart areas, we know the chart. Well, no. parent. No. Chart area. Oh, okay. Troublesome. Let me check. We might need a chart too. Chart areas. Let me quickly go through it. SS. Color, cursor, gas code, and shadow. Should be property. No. Shut down all the chart areas. Not likely. Okay, so not likely. Yeah, okay. So I need to know the chart too. So we need to change a little bit about the constructor. Yeah, I forget that. Okay. So we need, so universe is not just need the chart areas, we also need to know the charts. So kind of add a chart. The chart, we call it the chart. So we will ask the user need to supply that, not just chart area. In front of it, we get a chart. See there. All right, so we kind of bake it up. The chart. All right, the chart equal assign. We assign the chart. So for a universe, because in order to display it on user interface, we need to know the chart element. The ref is simply a reference. We are not create a new one. Okay, just reference the chart area too. So only in this case we can complete the mission or add a fuzzy set. So in this case, the series, the chart area has been assigned with this area, and then it's also the chart series. Add the series. Okay. So step by step, we try to complete the design of this fuzzy set and fuzzy set. So let's go back to the fuzzy set. So right now, if you user create a fuzzy set, then user need to provide universe, assign that new series, add universe. Try to add this. Well, before that, we need to generate a point, right? So we generate that. So we add generate points. All right. So how about the points? We need to know that the universe, right? We need to know the upper bound, lower bound of the universe. Lower bound, upper bound universe, right? And also the increment, right? We need to get everything from the universe. Right now it is in universe. And then we populated the point of this series, So we kind of for double x equal what? The universe. Try to access property, the universe. Lower bound. Right? Lower bound, start from lower bound. And x small equal the universe. Upper bound. I have not specified an upper bound yet. You should do that, okay? 你不要照曹老师套，我现在写死哈。10 point 记得在那个地方。All right. You need to do that. You need to complete the similar function. I kind of just create a property as a sample for you. You need to do the rest of them by yourself. All right. So later we'll see the universe. Oh, okay. We have another range showing that it's upper bound. Right now we have increment. We do not have upper bound. All right. So as a responsibility, right now I simply hard-coded into 10.0. All right. So x equal x plus the universe. Excuse me. The universe increment. See, everything. I mean, the resolution is not determined by the fuzzy set. It's determined by the universe, because a lot of fuzzy sets will share the same universe, right? So in that way, the resolution of the point should be the same. All right. Okay. So the x plus the universe increment. Then what should we do? Well, depending on your implementation. If you are not familiar with code, you can say I have a y ready, block variable ready there. And then how can you get y? Y equal what? See, we have a get function value ready then. although we did not implement everything, but it's okay. Once the function is created, then we will get function value, put x there. All right? So you have x, y, then the series can add up the point. It's a correction property. Add x, y, add x, y, right? It's similar. But right now, we have make this responsibility to the fuzzy set cell. 我没有广播嘛，你们都没有讲啊，因为至少我们电脑这边有，现在完全没有广播。这样你可以，假如说桌面上有那个电脑去看啊，下次提醒老师好不好？好，希望我们至少这个课程，因为这是 lab 的时间，希望 interactive 比较强一点，我们 save 一些 effort， 至少你桌面上有。好，所以 we cannot add x, y, so the point's already there. And then we ask this universe help us just recognize these series. So everything should be put there. Hopefully, you know. But right now, because nothing has been special, we need to get function value, right? But fuzzy set is already there. So this is a generic, I mean, it's a parent class or fuzzy set, right? So we have a fuzzy set, and we have a constructor. So constructor will ask that user supply universe. So then we will start our writing for adding another fuzzy set, add a specific fuzzy set. So click the project, and we need to add another class. So add classes. Right now it's a derived class. So suppose it's a Gaussian fuzzy set. Gaussian, Gaussian fuzzy set. Okay, so name the class name first. So we just prepare for that, and then right now it's inherit from fuzzy set. So we have a derived class inherit from fuzzy set. Why query that came out? Read it. Okay. It's series related to the constructor. All right. So if you want to instantiate an object of Gaussian fuzzy set, which is inherit from this parent class, and the parent class has a special because right now our fuzzy set do have a special constructor, right? It is not so-called default constructor. It's a special constructor. So in your derived class, at least you need to have a constructor to invoke that non-default constructor. So you need to prepare a constructor to invoke the parent constructor. So prepare the constructor CTOR, double click it. Or otherwise, let me try it to see whether IntelliSense will help us or not. Okay, IntelliSense will try to help you to see what else. Well, nothing good at all. Internal class. Well, it's useless anyway. So we need to do that by ourselves. CTOR. Hit tab twice. You see, the parent need what? The parent doesn't need the universe. So there is no excuse. You need to provide this parameter in the constructor or derived class. So we need to specify the universe. U. But the usage is like this way. Just put U there. Excuse me, this should be base. Right. This means that because this is derived class and the parent class do have a constructor, so this is the child. This is the constructor for the child class for the derived class, and then this class this constructor need to invoke the constructor or the parent. So this base meaning what? Meaning the constructor or the fuzzy set, and within the parameter list should be the signature or the constructor. 好，所以这样状况就是 U 拿过来 invoke 这个 U，invoke invoke a parent, the constructor parent, without just receive one parameter, one parameter or universe there. In this way. Since Gaussian, remember that Gaussian do a Gaussian inherit from fuzzy set, right? But here, if you try to access, see, if you try to access the inherit data, okay, the inherit data is called parameter value, right? But by default, it's private. It's private, okay. So if you want to inherit PAIME, nothing happened. The Gaussian fuzzy set right now inherit from the fuzzy set, but even though it inherits the parameters, so-called parameter name, because it's private, you cannot directly access it. But if you, since we are in the same family, if we don't declare that, we know we should not declare as public, right? Otherwise, user might change the value arbitrarily. So, but the derived class want to access it. In this case, we will specify the data accessibility as protected, PROTECTED. So this is the time you get familiar with the accessibility or so-called protected, private, public. Protected meaning what? Meaning all the families of this class, within this class, through the inheritance hierarchy, they can directly use this parameter. Even those the child class inherit this data, does not mean the child class can directly use this data, unless this data is protected. 好，所以这 protected 就才能起到。So make this data field protected for the derived class such that they can directly use it. So once fuzzy set the parameter value has been declared protected, then let's go back to the Gaussian. Then in Gaussian you can access this. You can see right now I can access parameter value in this time. So for the Gaussian function, how many value usually be instantiated for this parameter value? We know that, whoa, okay, since it's a Gaussian fuzzy set, right? So I can actually simply allocate 2, right? So by default, the parameter 0 will be the center, and the so in this case, as your parameter value, as I say, you should give it a meaningful what? A meaningful value. Okay? But how can I get this meaningful value? 0. You can say, well, I put into 5. But how about the universe? If the universe starts from 0 to 1, then your center value is 5. It's out of the range, right? So it is better that the initial value is dependent on the universe. So how can I do that? All right. So I like to, well, since the Gaussian for this, I like to put the initial value in the middle, as the middle of the range, right? So how can you do that? Well, I have a universe U, right? And I can access the lower bound, right? And if I cross its upper bound, but right now I do not have an upper bound, right? So I can put it 10 plus 10. Suppose it's upper bound 10 divided by 2. Somehow you can do that. All right, to make it, and probably we can also use the random variable, try to make it change a little bit, but right now it's fixed. All right, so all right, never mind. So how about parameter 2? Parameter value 1. It's a standard deviation. Well, I may probably use upper bound is 10 minus U lower bound. See, make sure it's positive. And probably divided by what? Or by 10. Never mind, it's initial value. Okay. All right, so it's initial value. So what is said, then parameter 2. How about the title, right? We need to set up a title. 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 Right. And since it's Gaussian, so we like to have GAUSS Gaussian, GAUSS IN fuzzy set 1, 2, 3, 4, 5, right? Similar. Okay, so how can we do that? All right, so back to our Gaussian fuzzy set, I might have static int count equal 1, and then kind of change it into count use suite string other side. COUNT++. So title is ready. Constructor is ready there. All right. So let us see what happened. Okay, Gaussian for this count one. I don't know. Later on, we will try it. So we have a Gaussian for this created. We have for this set ready there. Parameter universe series. So constructor for this set. Okay, probably this is not a good idea. Okay, because the constructor want to populate the series. Series has been nuded. Okay, so let us make a little bit modification about the point, because the point should be, well, should be what? Should be populated. Okay, get function value. Now it's an old value. So universe. Okay, it's not a good idea anyway. So let us go back to the file. So we try to, well, maybe it's okay. Maybe we should just provide update anyway. Update the series point. Okay. So we have public update. Update. Yeah, IES. Update series. We should not put it private. We should simply put it similar and just put that in there. So this function will be used within this class of family. Okay. All right. So update series and move this line. Okay, move this line to new series, array series 2. Yeah, move to this function. Update series. Okay, this is special in the generic class. So generic just invoke this get function value, and then so we go back to the Gaussian function. So after the title has been specified, then we will update series, call update series without anything. Okay, because series has been instantiated by the parent, right? So it's okay. But right now we need to see. Okay, so implement for this. So up to this point, we need to specify what? Because data has been extracted to the parent class. So we already has parent parameter value there, and we also have title and the universe series. But right now we need to specify the function, the function get function value, which is specified in the upper class virtual, right? So it's about the time we implement our own one, huh? Okay. All right, so in this point, you simply type the keyword O. The text should be override O. See, once you highlight O override, you can hit tab key. I think should hit twice. Override twice tab key. No. Yeah, let me check it. Class public override. Let me save it. If I just say do have public. If I just say public virtual. Alright, what's wrong? Oh, okay. Sorry about that. All right. So right now, we try to implement the override function to override the virtual function. So virtual function does not implement anything. But right now we need to, so type O, once intelligent highlight override keyword for you, you simply type a blank space. Type blank space. So intelligent will highlight those virtual functions can be overridden by this class. See, equal to string get hash code. This has been specified, has been derived from object, right? But how about get function value? Because get function value has been specified by us. in the generic fuzzy set class. So it's ready for you. So you simply navigate to the get function value, and then hit tab key again. Not again, hit tab key. So Visual Studio will prepare this override function for you. As you can see, the function skeleton is almost the same, exactly the same, except the keyword virtual override. Right. So otherwise you can type by yourself, yourself. So you can say, okay, public, you can type everything by yourself, override, and get function value one by one. And otherwise you can, ask the intelligence step for prepare for you. So in this case, it's built it, alright, so get function value. How can you do that? Similarly, how can you, what have you done in your get function value for Gaussian function? Simply return, right? You return mass. So you can see mass exponential, right? Minus x minus what? Center parameter value. So you can see right there. Time x minus parameter value, right? 0. And in front of it, 0.5, right? Time x minus c divided by parameter value 1 divided by parameter value 1, right? Okay, so this our information. Get function value is ready. Alright, so far so good. Okay, so initial value has been specified depending on the universe. Fine. Okay, so let's go back to the user interface. So right now we have universe, and then suppose we have user interface ready for the users. For example, we have combo box. Drag a combo box here. You should put some label there, right? So within this combo box, it's very simple. I just property items, especially available fuzzy set. So first one should be the GAUSSN Gaussian. Triangular. Anyway, doesn't matter. The most important property should be the selected index later on. So combo box selected index. Similarly, I like to change the name. Combo box CBX fuzzy set type. There. And then, so probably the user might have button click. Then ETN GIET. Oh, never mind, just new fuzzy set. So by the selection, and then once user hit the new fuzzy set, a new fuzzy set will be instantiated. Okay. All right. So subscribe its event here. So we will have a switch cases, right? Switch CBX fuzzy set type. We kind of pick up what kind of property. It's a property called selected index, start from zeros up to the count minus 1. So case zeros, meaning what? Meaning it's a Gaussian. Alright, so break. Somehow like that. So in our form object, the very beginning, you might think that, oh, okay, my universe, then they have a fuzzy set, FUZ0 here. We simply specify the uppercases. I mean, the name of uppercase is fuzzy set. So I call my fuzzy set. And here, since it's a Gaussian set, right? My fuzzy set equal what? New. Since it's Gaussian, right? So it's about the time we invoke this Gaussian fuzzy set. How about the universe? Remember that you need to instantiate a universe first, because we need to have my universe ready. Then we can create my fuzzy set. So we simply put my universe there. So up to this point, it's very rough. I mean, the user interface is very rough. So, okay, so let me try it, and I might set up a breakpoint. Try to do everything there. Okay, we have bug. So it's a no semicolon. Okay, the universe, right? So it's not consistent, right? So right now, as you can see, if you bump this kind of situation, you move to this place, highlight it, universe, right-click your mouse button, move to the definition, move, or just check what's wrong. So I did not intend to move to the definition or universe. I simply check the definition. See, the constructor or universe right now take two arguments, but right now I just initially I just put a chart area is not enough, so I need to put the chart there too. Okay, I understood. So close it. So the first one, and also you can just erase the reference, the type of reference again. IntelliSense will show you the signature of this constructor. So I need a chart. How about the chart? I call it the chart, right? Since you have the chart. So it's a piece of cake. Right now it's special 2. So up to this point, alright, so it's okay. Special 8. Still have problem. Alright, semicolon. I need to end it up. Semicolon. Type 8. So I can select Gaussian fuzzy set, triangle fuzzy set through this combo box. So this is the zeros. If I did not create any universe, if I hit this guy, what will happen? Okay, see, code came here. It's about to execute this one. So we try to new Gaussian fuzzy set. I enter it, enter the function. So error coming out, cannot continue. Exception happened. I did not see any exception. Right. 进制错 ，sorry。你看，重新再来一次。I still have bug. Okay, let me check it. All right, so this line has problem. All right, it's typo anyway. Make sure it's okay. Okay, so I select Gaussian fuzzy set, hit the key. If I hit F11, came to where? Came to the Gaussian fuzzy set. Start from Gaussian set, right? So right now, I try to invoke this constructor. I did not instantiate a universe yet. So move your cursor to the U. It's none. That will have any problem. Before the constructor has been executed, this parameter has been passed to the parent constructor base. So we are about to execute to move up to the parent class. So if I hit F11 key, came to where? Came to fuzzy set, invoke this constructor. So use that U. But right now U is none, right? So there is no any guarding condition. U still assigned to the universe. The universe still none. And then we create the series. And the universe, you see, the universe right now try to add a fuzzy set. So the code will crash right here because the universe is none. So exception happen. That's your application cannot run it. So in this case, you need to set a full proof. You are not let the user hit this key initially. You will make sure that a universe has been created, and then this button is ready for the user. 所以你必须要做黄笨哈，要 full proofs. So usually we will specify this button what? The enabled tend to be false, right? 所以你要思考一下这个人机界面逻辑，你不能一开始这样做就会垮掉哈。所以 if I set it to disable right now, so I cannot hit this guy. I can select one is hundreds at all, so I cannot hit this guy. It's okay. Make your application full proof. So right now we try to create a new universe. So it's okay. It's done. Right now, universe 1 has been done. But once a universe has been done, then this button should be enabled, right? So you need to modify your logic back into your user interface. 所以在这个地方 once the universe has been highlighted, so back to this environment, this quick event. So I create chart areas, instantiate universe, set a property to this guy, right? So this time, btn create new fuzzy set enable true， 你要做把关的动作哈。你要思考啊，这个可能还会回来再 disable 掉。you need to make that change by yourself. All right, it's ready. So Gaussian fuzzy set, new fuzzy set, similar. Line by line tracing. Okay, so we are about to invoke the constructor or the parent class. We can do here. You do have a value, right? You do have a value specified. Okay, the lower bar has changed to minus 10, 10. So right. So step by step, universe and series has been instantiated. And then we are about to ask the universe add this series to its chart area. So we hit F11 key, can do this universe again. The series is instantiated. It's okay. And how about the chart area? So chart areas. And then chart area 1 assigned to the chart area. Series. Initially the chart does not have any series associated, right? So series has been added. So it's okay. So for this set constructor has been successfully up to this point. Alright, so universe has added. Then once the code complete the constructor or the parent class, then it start initialize the constructor or the child class. So initial parameter is none, right? But for a Gaussian, we know we will allocate 2 double value to store the parameters. So 2 has been allocated. So how about the initial center? Or I kind of use upper bound or lower bound, try to use middle there. It's okay, but it's not good at all because if we use a create a lot of fuzzy, they should be overlaid exactly. It's not good. We should have. You should use a random number, generator to change it to alter the value a little bit. But within this, still within this range of the universe. So zeros first. How about a title? Initial is none, right? So it's a Gaussian 1. So Gaussian fuzzy set 1. Update series. Where is update series? Update is special in the parent. So came to here. Okay, we came to here, right? Update series, right? It's special in the parent. How about the x start from what? From low bound minus 10. Upper bound did not do it. So how about increment 0.2? So 100 point was generated. So through this point. But how about get function value? See, we are in the parent class. We are in the parent class fuzzy set. How about the get function value? Function is right here. This line simply return 0. But it's virtual, since it's virtual. But right now we are about to execute the get function value, right? But what kind of object you are really dealing with? The object is a fuzzy set, fuzzy Gaussian set. It's not the fuzzy set. So what would happen? I hit F11 key. It came to the Gaussian fuzzy set. Came to this override function. So that is the beauty of so-called polymorphism. Polymorphism meaning we have a generic function declared in the upper class, but derived class has its own implementation, dynamic invoke. So this function will be invoked to generate a point for you. All right. So as you can see right now, series has been showed up right here. It's not incorrect, right? Because initially, by default, the series, if you did not declare anything, the chart type is what? Chart type is histogram. It's a column type. So we know that, all right, so back to the fuzzy set. Once we need a series, we need to set some property. The series chart type, right? By the code, chart type equal what? Chart type line. Line is a line. Okay, so new universe. So we have one universe right there. And we select Gaussian fuzzy set, new fuzzy set. Okay, let me remove the breakpoint. Let me continue to the end. All right, so we have a fuzzy set there. All right, so if I hit this button again, new fuzzy set, what will happen? They are overlapped together, so it's not a good initialization value. Okay, again 3, 4, 5. So keep going. Alright, so we kind of go back to the Friday set. Okay, so if your Gaussian Friday set needed to use a random number generator in order to generate initial value, right? So you can put a random number generator object here, but it's not shareable by the rest of the Friday set, right? So we had better move up to the parent class right here. So I kind of protected random. I call it RND, and I knew it directly. So every child class will inherit RND. So for their own purpose, they can use the random number generator to do whatever they like. Okay, so that's the idea. So let's go back to the Gaussian Friday set. All right, initial value not just this rigid. So I might probably upper bound middle, right? So I might, well, how can I do that? So the center, I might maybe use U upper bound. There's no upper bound, right? So I use 10 minus U lower bound, right? So minus lower bound. It's positive value. And then I might type rand dot next. Dot next mean what? Random number generator dot next mean excuse me, next double. Check that function. This function will return a random number, real number. The values start from 0 up to 1.0. So I time this guy, and then plus U lower bound. So that random number decided the center for this Gaussian function for me. That is the purpose. And how about the standard deviation? Oh, okay, still use the random number generator, right? And next double. And probably the upper bound might be what? Might be the U upper bound 10 minus U lower bound. Anyway, this is the range, right? So range might, it's not, probably not good at all. The range might, well, kind of tiny 0.5. Make it smaller. The standard deviation smaller. So in this case, I have an initial random value generate for the center and the standard deviation time 0.5. Okay, so right now, my Gaussian Friday set the title were running with the name Gaussian Friday set 1, Friday set 2, Friday set 3, and the center and the standard deviation were all different anyway, but still within this range, governed by the universe. Okay, so universe first. Select Gaussian, new Gaussian Friday set. Second one, third one, fourth one, fifth one, sixth one, right? Okay, sounds okay. But how about the series one, the name? See, each series will have a title, right? Why not I just use the series name, the Friday set's name to name the series? So go back to the Friday set. I think this should be the Friday set. Title. Title has been update series. Okay, title. Well, titles up to this point. Update series. So, well, I might. Well, it's probably is not good. So, highlight this function. I go to the definition. 移到下面来. So simply update the point, right? Update the point. Now we have to do a change. Okay, so maybe title has already fixed. So well, series have been used. All right, so probably that is the responsibility. That should be the responsibility of each derived class. Okay, so title is right here. So I will let the Gaussian function do the dirty job. So the series, there's a title, no? The series name, Yeah, also this name equal title. To make the legend appear, I mean, consistent. All right, what's that? So new file set, 高写file set, 高写 2, see, 高写 file set 2, 高写 file set 2. All right, so make it that consistent. But how about the parameter change, right? I like to the user change the parameter, right, for the Gaussian center, for example, like that. So how can we do that? All right, so back to the Gaussian file set. The value has been stored in where? In parameter 0, parameter 1, right? The beauty is right here, okay? So we cannot define property. Right? So, okay, so since it's a property, right? So it should be property double. Well, I call it a center or mean. Anyway, okay, this time suppose I like to name it as mean. Fine. It's a property, not a data field. Okay, so that should be the pair process. And then how about get? How about set? Similarly, we can define this property. So we call it mean, right? The name is meaningful. The property is mean. The other should be standard deviation. So how can you get it? Where did you store the mean? Well, return. See, parameters value, zeros. You have instantiated it, right? You have knew it, and you put a center in the 0. So real data is stored in the parameter value 0, but it appears to be a property. Name is mean. That's the beauty, okay, of the property mechanism of C#. And how about the set? If we try to set it center, probably there should be no any regulation about the center, right? Because center might be larger than the upper bound or lower than, or it's normal. So we will not have any restriction on the mean. So we simply parameter value 0 will accept the user specification. User specification has to put in value, right there. But how about standard deviation? I kind make a copy directory, and I call it std. Or you can spell the full name, spell it out. It's much more better. So return 1. How about a setting? Well, if value should be larger than 0, then I will do it. Otherwise, I will not going to change the standard deviation value at all. See, that is the guarding mechanism there. All right, so right now my Gaussian file set has a property mean and a standard deviation. How can you show it? Well, okay. In this case, back to this. Once the user create a new file set, then I will use property to show the property of the file set for the user to modify. So the idea is similar, like the universe. So right now, if I instantiate an object, although my file set has been specified, well, it's very simple. So right here, I kind of show what? Property grid, property, P-R-O-P-E-R-T-Y. Property grid. The property grid, excuse me, the property grid. Selected object. See what? My file set. It's very interesting, okay? See the mechanism. So, okay, so the universe right here. Gaussian file set, new file set. As you can see, mean is there. It's initially specified by the by the random number generator, right? So user can change it change it into probably 5. Enter. It's okay. How about standard deviation? Change it into 2. Through this so-called probability grid. But nothing has been changed, right? Yeah, you need to update the series point by yourself, right? Once user change the mean, once you change the standard deviation, right, you need to update your point. So how can you do that? So let us go back to our Gaussian function set. I have mean, right? I have changed the value. So what? So you need to update your series. So I can just use update series. See, I call the function, right? Because my parameter has been legally changed, right? So I need to invoke that. So once this condition passes the guarding condition, then I will update the series point. Update series. It's meaningful. Yeah, it's meaningful. But let us go back to the update series. See, highlight it and move to the definition. It is specified in the defined in the alpha class right here. So the series point A, right? So you will add up the old point. So before that, as you can remember that we need to clear up the point. It's not a good idea, but you need to do that because you kind of keep using memory, use memory, and then create it, and then create another 100 point, create another 100 point. It's not good at all, but it will do anyway. It will make your data display correctly. Later on, probably you will think about if I stick on 100 point, I simply change the y value. Okay, we are not create it and add a new one in order to save your memory later on. Okay. So universe. So that is about the time you can change it. For example, if I change it into the maybe well, I should not change it because otherwise you will screw up. So Gaussian, new Gaussian, right? So the Gaussian means 2, 7. Standard deviation. If I add up situation, maybe change to 5. Once you complete typing, you need to either way hit Enter key or move your cursor, click on other place, make a change. Do I see it changing? No. Change it to 1. Okay, hit another way. It is keep changing right now. So through this property grid, you can accomplish the user interface functionality. So you don't need to bother about label text box at all. You just use this text box, and also automatically. You see that I did not take care anything of the curve at all in the main phone object because the data has been specified in the fuzzy set. So we should let the fuzzy set do the update by themselves. Okay, this is the whole idea about object-oriented framework. Okay, I think it's about the time I should end up here. We still have a lot of trouble, you see. Later on, if you add another one, okay, this is another one. You can see this. How come? Option for this. Okay, the second one. So the only one I can change probably this one, 5. And if I add the third one, the line I can change might be the new one only, right? So this user interface is not good, okay, because sometimes, well, I need to select existing fuzzy set changes, right? But right now the user interface does not provide us such kind of flexibility. But okay, so far I mean for this assignment, you simply probably, well, up to this point, if I create another one, if I create another fuzzy universe. So right now, because I simply have a universe, right? So this is the universe that I can handle. So if I add a new fuzzy set, it is added to the new one. I cannot modify the older one, right? So this user interface is not eventually what we want. We need to keep it with. Because the problem right now is that because in the main form, we simply have my universe updated. My universe updated in my fuzzy set can be selected. So it is not what we want. But I think the time has been a little bit over. So I will stop it right here. I will go back to thinking properties. I will edit up some video shooting to guide you. We are not going to use this chart only. Actually, we like to have think I need to make a video shot for you for the rest of assignment 3, because we will have another control called what? Called tree view. So we will use that. All right. So up to this point, you just focus on what I have teach you. Try to do what? Do the rest of the fuzzy set declaration. For example, we will have a triangular fuzzy set. We will have a Bayer fuzzy set. Try to do it in a similar way, and then complete the list. So the combo box will list out every possible constructor, and then try to complete this function set. I will show you how to store the created universe one by one within this so-called tree view for the video tab. Probably I will release the video tab probably within 2 or 3 work days. And then the deadline will be extended a little bit somehow for the assignment 3. 好，所以老师会再跟大家讲这个 tree view 怎么用。好，原则上 we will display the universe and the fuzzy set in a hierarchical way. So you will see in the first layer that should be the fuzzy set. All right, fuzzy set. So how many fuzzy set? Excuse me. The first label should be the universe. So if you create 2 universes, so one universe will show up in the first layer, and then within the second layer, fuzzy set will be defined within that. 这是我们要用的 user interface 哈。所以我回去会把这部分完成这个demo， 然后你们 follow 它。那 assignment 3应该要完成这个简单的这个界面，好，那包含这个所谓 property grid， 我们会一再使用它。So later on, once you click on an item of this tree view control, if it is a universe, then the property of the universe will pop up within this the only one property grid. If a user click on a fuzzy set, then the fuzzy set, the property can be all will show up right here. 好，这是我们 purpose。好，我们今天到这边哈。那抱歉，我们讲的比较乱，那你们回去要赶快哈 ，keep up 这个 with 这个 progress up to fuzzy set 那个 design 哈，这个已经差不多 almost complete。What I need to add on probably just the management of the main form 哈。So we will have a tree view control to host all the created universe and fuzzy set. Anyway， 好，我们先到这边。